Alright family, in this video I'm going to share with you this question that came under linear programming maths paper 1. Okay, so if what I'm doing in this video is what you're interested in, please consider giving it a like, share, comment, as well as to follow the page for more information like this. So without even wasting much of your time, let's dive in. So the question says, write the four inequalities that define the unshaded region R on the diagram below. Okay, so this question doesn't miss in an exam. Most of the times it is always there, and you need to understand that this question carries 5 marks, so you really need to put in as much effort as you can so that you can obtain all the 5 marks. Okay, now what you need to understand is that when they say write 4 inequalities, it simply means that 3 lines, they are going to carry 1 mark, 1 mark. Then 1 line is going to carry 2 marks, making the total marks to be equal to 5. And mostly the lines that carries 2 marks are those that cut on 2 axes, which is x and y. Now, before I even try to answer this question, just to share with you some background information that you really need to understand. Okay, so when it comes to linear programming paper 1, specifically I'm talking about paper 1, so please, the information that I'm teaching you right now is for paper 1 questions. Okay, so you need to understand that we have 2 types of lines in linear programming paper 1. We have 2 types of lines. Okay, so we have what we call solid lines, as well as the dotted or broken lines. Now what you need to understand is that in solid lines we use 2 inequalities. In solid lines we use 2 inequalities which are less than or equal or greater than or equal. Then in dotted lines we use less than or greater than. The difference is that in solid lines we are having the equal, while in dotted lines we just go direct, either less than or greater than. Okay, that's the key you need to take note here. Now there are many things that you need to understand, but more I will explain as we are answering this exam question. But don't forget, again, the question says write the inequalities that define unshaded region. Let me just explain about that. Unshaded region. So you are actually writing the inequalities that define the unshaded region. Now see, for example, let's say you have been given this one here as your y-axis. Then we do have a solid line. Let's say I have got a solid line here. Then this solid line has been shaded down here. Okay, this solid line has been shaded down here. Then here it is cutting at 4. So you need to understand that this part, the part that is not shaded, the top part, this is the unshaded region, while this one here is a shaded region. So as you are giving inequalities, you need to give inequalities in favor of the unshaded region, not the shaded region, but in favor of the unshaded what region. So that is what you need to understand. Okay, I'll explain more as we are answering the exam question. So like we earlier read the question, it says write 4 inequalities that define the unshaded region. In this case, you can start with any line here. You can start with any line. So from here I can tell that this line here is going to carry 1 mark. Same applies to this line here, is going to carry 1 mark. This one is going to carry 1 mark, while this one is going to carry what? 2 marks. Okay, so the first step, I'm going to start to say this is question 21. Okay, question 21, inequality 1. So inequality 1, I can start with this one here. So the first thing is to identify the axis where the line is cutting. So in this case, this line here is cutting on the y-axis at 4. So the first step here, we're going to say y is equal to 4. That's the first step there. Y is equal to 4. Now where there is the equal sign here, we need to replace with the inequality. Now what type of inequality? Remember, this is a solid line. So it either we are going to use or equal, or we are going to use greater than or equal. Now between the two, which one? that's when you ask yourself a question in the region that is not shaded. So as you can see from here, we know that from here, the up region here is the part that has been shaded, and the down region, this is the part that has not been shaded. And as you can see from here, we can tell that from here going up, the numbers are increasing, so this is the greater region. Then from here going down, the numbers are reducing, so this is the less region. That simply means that the region that is not shaded here is less, so we are going to use what? Less than or equal. Okay, so we are going to say y is less than or equal to 4. This is our first answer there. Let's try to proceed. The next one, we can pick another line. In this case, I'll go with this one. So remember, the first step, you identify the axis at which the line is cutting. So in this case, this line is cutting on the x-axis at 1. So we're going to say x is equal to 1. Okay? Then now, where there is equal sign here, you need to replace with the inequality. So what type of a line is this? This is a solid line, okay? This is a solid line. So since it's a solid line, we are using less than or equal or greater than or equal. Now, between the two, which one? That's when you ask yourself. As you can see, from here, this is the right side of the line, and then this is the left side of the line. So you can tell that the right side of the line here is not shaded. The left side is shaded. Now, as you can see, from here going this side, the numbers are increasing, so this is the greater region. Then from here going this side, the numbers are reducing, so this is the less region. And remember, we are writing inequalities that are defining the unshaded region. So from here we can tell that the unshaded region here is greater, because from here going this side, the numbers are what? Increasing. So that simply means that x is greater or equal to what? To 1. Like that. Okay, then let's go to number 3, the inequality number 3. So we can go to another line, which is this line here. Okay, so remember, the first step, you identify the axis. So this line is cutting on the x-axis at what? At 5. So the first step is to say x is equal to 5. You identify the axis. Okay, then the second step is to make sure that where there is equal sign, you replace with the inequality. Okay, so now what type of inequality are we going to replace here? That's when you ask yourself a question to say, what type of a line is this? So as you can see, this one is a solid line as well. It's a solid line, so we are using less than or equal or greater than or equal. Now, between the two, which one? That's when you ask yourself the part that is not shaded. Is it less or it's greater? So from here, we know that the right side of this line is shaded, while the left side of the line is not shaded. And as we can see, the left side here, from this point going this side, the numbers are reducing. So this is the less part. Then from here going this side, the numbers are increasing. Of course, if we had numbers here, we could have increased by 6, 7, and so on. Okay, so since the numbers are reducing here, that simply means that the region that is not shaded is less. Okay, so from here we are just going to say x is less than or equal to 5. Why am I using less than or equal? Because this is a solid what? Line. All right, I believe we can try to solve the last question. For the last question, which is the fourth inequality, you need to understand that this question here, this line here, you need to understand that this line is going to carry 2 marks. This is due to the fact that it was cutting on 2 axes, which is the y-axis as well as the x-axis. Okay? Now, what do you do here? So the first step is to pick the coordinates. Pick the coordinates. You need to pick the coordinates here as well. So I'm going to start with the coordinates that are here. Okay? So the first coordinates, as you can see, this is the y-axis. So that simply means that here at this particular point, the value of x is supposed to be equal to what? 0. So meaning the coordinates here will be equal to 0, 3. Why am I having 0 here? Because this 0 is coming from the x-axis. Okay? Set of coordinates. We are going to pick the coordinates here. So as you can see, this is the x-axis. So that simply means that the value of y here will be equal to what? 0. So the second set of coordinates will be equal to 5, 0. Okay, so to find the gradient, we are going to use the formula, which is gradient is equal to y2 minus y1 over x2 minus x1. So from here we're going to say y2. So from here you know that this is your x1, y1, x2, y2. Here the y2 is 0 minus the y1 is 3. So the y1 is 3 there, over the x2 given is what? 5 minus the x1 given is what? 0. Okay, so we try to subtract here. We're going to have 0 minus 3. We get negative 3 over 5 minus 0. We are going to get a 5. So that simply means that the gradient here, the gradient was equal to so the gradient was equal to negative 3 over 5. This is the gradient. Upon getting the gradient, we can now find the equation using the formula, which is y minus y1 is equal to mx minus x1. Okay, so from here you just use one set of coordinates. If you want, you can use this set or you use this set, but nevertheless any of the set of coordinates that you use, you are going to get the same answer. So from here I'm going to use this one here. So remember, when you are using this formula, where there is y, the first y here, you don't replace anything. y1, we are going to have a 3 there, equals the gradient given is negative 3 over 5, x minus the x1 given is 0. Okay, so from here we're just going to solve this by saying y minus 3 2. We try to multiply here, negative 3 multiplied by x, we are going to have negative 3 over 5x. Then we know that we are still going to get a 0, so there is no need to write this. Then from here we can just group the like terms. We are going to say y is equal to over 5x. This is negative 3. The additive inverse will be positive 5. Okay, so that is what we are going to have there. So this is the equation. Even if you use this set of coordinates, you are still going to find this equation as long as your calculations, oh sorry, 3 here, 3 not 5. So even if you use this set of coordinates, you are still going to get the same equation as long as your calculations are correct. Okay, now when we reach at this stage, it doesn't mean you are done. We are not done. What we need to do now is to make sure that where there is equal sign here, we replace with the inequality. So what type of inequality? That's when we ask ourselves to say, what type of a line are we dealing with? So this is a dotted line. As you can see, this is a dotted what? Line. And since it's a dotted line, that simply means that we are going to use less than or greater than. Now between the two, which one? That's when we ask ourselves the part that is not shaded. So as you can see, from here going this side, numbers are reducing. Even from here going this side, numbers are what? Are reducing. Meaning that this is a shaded region, you remember. So the shaded region is less, while the unshaded region is greater. Why? Because from here numbers are increasing, even from here numbers are increasing, meaning that the unshaded region is greater. So that simply means that from here we're going to conclude to say, therefore, y is greater than negative 3 over 5x plus c 3. So this is our final answer. Okay, so this is what I had prepared for you in today's session. Hopefully you have been able to get 1 or 2 points. Don't forget, we are here and we offer both physical and online lessons. The number is 0974 98 07 75. And for the grade 12s, I do have good news. We are soon starting our night camping. So please, for more information, you can use the same number. Thank you so much for watching.